Welcome everybody to Mission Control Houston. This is the International Space Station Flight Control Room. We'd like to welcome the Alvarado Junior High School right into Mission Control. And joining me, I'm Kyle Herring with the Public Affairs Office here at the Johnson Space Center for NASA. And joining me is Megan Hashier. And Megan is a space station flight software engineer. I think I got that right.
Yeah.
And so she knows quite a bit about how the software works, and testing and simulation and getting it ready to actually work on board the International Space Station, which is flying above us 250 miles. So we're excited to have you guys join us today here in Mission Control, and I think we're both going to try to answer y'all's questions. Michael, we're ready whenever you guys are.
Do the astronauts ever get tired of floating around?
Personally, if I was in space, I wouldn't get tired, I don't think, but I couldn't answer that because I'm not an astronaut.
I think that astronauts don't get tired of floating around in space. In fact, it's pretty easy to do that. If you've ever seen them on television, it's pretty much effortless after they learn not to bump into things. In fact, you're looking right now at a live picture inside the station of one of the new crew members on board as he's working on a science experiment in the station. So I don't think they get tired at all of floating around. Great question.
Hello, my name is Cameron Gunn, and if you held your breath in space, would you possibly float down to the floor like in a pool?
I don't think you would. Typically, they are breathing normally and they're not moving around a whole lot unless they're pushing off something because they are weightless. They do practice some of their extravehicular activities in a pool because it can help simulate weightlessness, but they don't actually sink when they breathe in deeply up in space.
Right.
My name is Mallory Sauter, and if a damage occurs, can you find a way to repair it, or do you have to leave right away?
That's a good question. And I think in general, they try to repair it if at all possible. I know last year in the news, I think it was in the fall time frame, they had a problem with one of the power contraptions, and they actually put out in the news that they used a toothbrush and some wire to help loosen a bolt so that they could replace the unit.
Right, but there's a lot of contingencies and precautions that crews train for in order to repair systems on board the station. It's a very big complex, and so we train pretty heavily these crew members to fix just about anything on the station. So, but that's a great question.
My name is Drew. Do the astronauts control the navigational system on the ISS?
A lot of the control of the navigation system is actually done by computers in the flight software. The controllers in mission control and the crew can send commands to do maneuvers, but the software actually is the thing that does and performs the maneuvers with the hardware.
And if we have a wide shot of this room, there's a flight control position actually in here that manages the flight software, that watches over all of those computer systems, the overall command and control system, right?
Right.
Great question.
My name is Ashley Ramsey. When you get back home on Earth, does it take time to adjust back to gravity? And if it does, how long does it take to get back to normal?
Well, it depends on what they're adjusting from, but typically it does take them a little bit of time to adjust. I think on average they said in about 3 days any kind of nauseousness or anything like that from returning it has dissipated, but they still have to work on regaining the muscle strength and bone strength that they had prior to going up in space, because they do lose some of that while they're up there since they're not using their body like they normally do here on Earth.
We've learned a lot after so many years of space flight, and especially on these long duration flights like this. The flight doctors have a very strict exercise protocol for the crew members on board, so that when they do come home, it tries to reduce that time that it actually takes to readapt to the one gravity environment that we feel right here. So On the order, I think they have a protocol of about 45 days or so after landing that they kind of use as a rule of thumb, but that's not hard and fast. But that's a great question. It's about a month and a half.
My name is Hannah Wright. What is the biggest worry about going to space?
I think in general the biggest worry is keeping the humans that are in space alive. And the environment in space is vastly different than here on Earth. And so they have to worry about a lot of the environmental things, making sure there's air up there, making sure that it is a livable environment for them because you're going into a vacuum where there's nothing like that.
My name is Brandon, and I want to know what college you have to go to work at NASA and be an astronaut, and what you have to study.
Now, I personally have not heard of any specific colleges that NASA says you have to go to. I think more what they look at is what classes you've taken and how you've done in them. For a lot of the people I work with personally, they have degrees in engineering or physics or some kind of science or math, or they have a computer science degree. And a lot of the classes they look at you taking then are the sciences, the engineering, and the computer programming. Now, I know they also have a business division here so that somebody actually manages the money for the engineers. And so I know there are a lot of people who get their MBAs or their business degrees to be able to work here.
So there's a whole vast array of the type of degrees that you can study to work in the space industry if you want to, the aerospace industry. So, but math and science is kind of a staple because if you understand those kind of studying habits, then that can translate into just about anything you do in the aerospace industry.
And I know for me personally, a couple of my physics mechanic classes, so like the orbital mechanics, how things move, have come in handy a lot.
I've had a great deal of help in that regard. Great question.
Hi, my name is Sierra. How does the ISS get out of the way of space debris or asteroids?
That's a good question. They have thrusters on board the space station, and they also have vehicles docked that have thrusters, and they use those to move out of the way of debris, providing they can find it ahead of time. But they've got lots of people keeping an eye out on all of the debris that is up there.
Exactly. There's we track, make sure that we track any kind of space debris of a certain size that we can tell when it's going to come anywhere in the vicinity of the station, and so. And that's watched very, very carefully. And so the station, as Megan says, can actually maneuver ahead of time and be in a little bit different orbit so that it will be completely out of the way of any threat like that. So that's a good question.
Hi, my name is Rachel. What are the first steps if there was a major problem with the computers that control the ISS?
I think this is probably Megan's area.
Yeah. There are a lot of computers aboard the space station, and I think the last count I had heard was something like 52 different computers. Now, they're not all running at the same time. We have a lot of backup computers, especially for the command and control computers, the ones that interface with everything. There are 3 different computers. One is used at a time, one is on standby in case the first computer goes down, and the other one's on standby. And then on top of that, we have another system in place that would go to redirect things to a different system so that we could still command and control the space station. And I think the easiest answer is we have lots of computers so that we can replace things as needed. And one of the good old standbys is to power cycle the computer like you would if sometimes you get a blue screen on your computer where you turn it off, let it sit for a couple minutes, and then turn it back on to try it again.
Hi, I'm Sam. When descending to the Earth, does the size of an object determine whether or not it will burn up?
Yes, it's actually dependent on a couple things, the size of the object and how fast it's entering the atmosphere. If it's going pretty slowly, it's more likely to hit the surface of the Earth because it's not creating as much friction for it to burn up. And I think the last figure I saw was if it was under 25 meters in diameter, it's more likely to burn up in the Earth's atmosphere.
We have some visiting vehicles that we call them that deliver cargo to the station that burn up in the atmosphere, and some of those pieces make it to Earth, but they target the reentry so that it's in the ocean and it would not harm anybody on the ground. But most of the pieces burn up because of that friction that Megan talked about. Good question.
Hi, my name is Mason Stevens. Does the ISS fly in space, or does it just stay in orbit around Earth?
The ISS stays in orbit around the Earth. You could really be considering the ISS to be falling towards Earth and is making corrections so that it doesn't actually go towards Earth. But in the early days when it was being assembled, parts of the space station did fly.
Yeah, it's a like Megan says, it's a constant free fall, but it's traveling 17,500 miles per hour, so it's constantly falling around the Earth at the altitude that it's at right now, and so it never actually comes down to the Earth. And we adjust its orbit a little bit here and there, like we did yesterday afternoon. Fired some thrusters on one of the Russian vehicles on the station just to tweak its orbit just slightly, which we do periodically to set the stage for rendezvous with upcoming vehicles. And so we do adjust the orbit every once in a while, but it's I guess it's always flying, but it's always free falling around the Earth too. So it's kind of up to how you define the word fly. Great question.
Hi, my name is Seda Hippolito. What exactly are you studying in space? What can be studied and why?
There are actually a lot of things being studied in space. One of the biggest things I think right now is how the human body will react to being in space, because one of NASA's goals in the long term is to go off to Mars, and people will be in space for a long amount of time for that. And so they want to know what they can do to help the astronauts to be successful in that. And I know they've also got experiments going on for radiation and different materials for how they will help protect the astronauts from radiation from things like solar flares from the sun, which provide a lot of radiation then to the space station when that happens. I think there's also a bunch of physical science experiments up there. Pretty much anything that can be studied in microgravity, they're trying.
Absolutely. It's now that it's a operational laboratory, it has been, but now that it's completed in terms of assembly, we have 6 crew members up there right now, and they're pretty much all 6 in different areas of the space station, which is a very huge complex. If you picture a football field, the station flying low over that football field would basically cover the whole football field. So, and there's at least 3 or 4 different scientific laboratories where experiments can be going on all the time. And the crew actually can be working directly with an experiment or activate an experiment, and then the scientist on the ground can interact with it from the ground, and then have the crew provide some assistance where needed. So it's a very interactive and collaborative process with science experiments on board. Good question.
I'm Landon Wooten. What would happen if someone that lived on the space station did not work out? How would that affect them when they got back to Earth?
That's a very good question and timely question.
Yes, the astronauts, if they don't actually work out in space, their muscles and their bones will actually start to weaken a lot more significantly than they do by working out. And I think I've read somewhere that astronauts have to work out up to 4 hours a day every day to make sure that their muscles and bones don't weaken. Because what happens is when you get back to Earth and you've got the gravity, all of a sudden you've got a lot of pressure on those bones and muscles, and if you don't work out, it could cause breaks in your bones and that kind of stuff, and it ends up being a really bad and painful thing for the astronauts.
And it kind of is part of one of the early questions that was asked about how long does it take to get back to normal once you get back on the Earth, and that's a great question, because we've learned over the years how to counteract the changes that occur in space. Those same changes happen to us here on Earth as we age over years and years. It happens to astronauts, and within a couple of days sometimes, some of the changes that occur. And so learning how to counteract that in space helps us on the ground in developing protocols, exercise protocols for maintaining your systems even on the ground as you age over time. So exercise is very, very important in rehabilitation to what we feel here on Earth again. Good question.
Hi, I'm Cameron Graves. How do you know where you're going? when you cannot tell if you're upside down?
That's a good question. I actually read a lot of the labels on the space station are all facing a certain direction, and so that's one way they can tell is by what way the words are facing as to whether they are facing what's considered up or down. If they're near a window, they can look to see what's out the window to know if they're looking towards Earth or if they're looking towards pretty much space or the sun or whatever it is that that window is pointing to. And I think they, in general, their mind comes up with some kind of sense of what's up and what's down.
Yeah, that's one beauty about the space station is there for them there's no up or down in terms of their working environment or sleeping, that type of thing. But it is like Megan says, it is oriented a certain way in terms of labeling, so they do have that sense of up or down. But in the true sense of the word, the way you and I feel it on the ground, there's definitely up or down for us, but not for them up there.
Hello, my name's Garen Shackelford. What materials do you use that you don't burn during your descent?
That's a good question. And I actually went online last night to see if I could find out what the Soyuz vehicle actually uses, because that's what typically is flying our astronauts up and down right now. And I honestly, other than some lightweight, high temperature material, that was all I could actually find on that. I know on our space shuttle we had insulated tiles that were heat resistant, and they also had thermal blankets and that kind of stuff to help give more layers between the astronauts and the reentry.
Right. Good question.
My name's Nikki Morgan. How much training do the astronauts on the ISS have to prepare for emergencies?
The astronauts go through years of training. Before they even officially become astronauts, they go through a lot of classroom training, a lot of survival skill training to learn a lot of the information they need to know. And then once they've actually been selected as an astronaut and they're grouped up with a team, they start working and doing simulations. And a lot of those simulations not only help them to do their jobs and the experiments that they're going to perform up on the space station, but they also have to go through what they would do in an emergency. And that's probably one of the biggest things that they go through, and they run through them time and time again. I think I read somewhere that it was way over 300 plus hours that they actually train for that kind of stuff.
Right. And not only the astronauts, but everybody on the ground goes through the type of training for any emergency case as well. Every one of these people that you see in this flight control room have gone through extensive training. In fact, they do training when they're not in the room for maybe a future flight. And then the work that Megan does on software development, and that has to be thoroughly tested, and they do simulations probably on that, just like the crew trains for a flight. You guys do the same thing, right?
Oh yes, our flight software goes through extensive training. I think it goes through 2 years of testing and simulations before it actually makes it on board the space station.
Yeah, it's a great question. And in fact, yesterday, the crew members on board, 4 of them, the commander and the 3 newest crew members, went through a training exercise, not directly emergency, but they did go through procedures that if there was an emergency, where they would go, just like you would in your school for a fire drill, exactly what procedures you would go through to make sure that you were safe in the event of an emergency. They do that on the space station, and they do it quite regularly to stay proficient. Great question.
Hi, my name is Dwayne Spradlin. How long until artificial gravity is invented?
That's a good question. And I'm really not sure of the answer on that one. I think it's still a ways off. I think right now what they're mainly focusing on is how to have humans survive in the microgravity environment instead of trying to simulate gravity.
Yep.
Hi, my name is Shadis. What would the crew do if they did not have enough fuel to return to Earth?
You know, I'm not entirely sure what they have in their procedures for this one, but I think in general they try to have a vehicle on standby that they could always send up in case of emergency.
Yeah, the spacecraft that they fly to and from the space station right now, it's very well calculated, and they would know even probably before they got to the space station if they were not going to have enough fuel to get home. And so it's very well organized and understood beforehand how much fuel they have on the spacecraft itself. The space station has plenty of fuel. There are vehicles that come and go from the station that actually deliver fuel, so they kind of fill up the tanks, if you will, on the station, so that those maneuvers we talked about earlier, those can take place whenever they're necessary. The smaller spacecraft that deliver the crew to and from the station, they always have reserve fuel that's on board, and they calculate it very carefully, so they know exactly how much fuel they have, and they know that they have enough to get home, whether it be in an emergency or when they're actually regularly scheduled to come home. Great question.
What would happen if the ISS was knocked out of orbit?
Knocked out of orbit?
That's a good question. I don't see it necessarily getting knocked out of orbit, at least not with astronauts on board. They would use thrusters to help put it back to where it needs to go. They do have thrusters, again, actually on the space station and on the Soyuz vehicles that are always docked there. And those would all be used to help get it back to where it needs to be.
Yeah, if it was something, I'm not sure your question, but if it's something big enough that that actually hits the station and moves it, it would be something severe enough that would probably cause the loss of the vehicle or require the crew to leave in an emergency. But if it's something as simple as we lose command and control function for a while, which we have done, the station might be in what they call like free drift, right? That where it just changes direction or changes its position, but the thrusters or the gyroscopes on board could actually maneuver it back, like Megan said.
I believe that was our last question for you today. Thank you very much.
Oh, well, we're very happy to have y'all come into the room and join us.
Yes, thank you.
Thanks
you
a
guys
lot,
had
everybody.
Great questions.
Appreciate it.
Thank you.
Thank you.
All right, and Kyle and Megan, thank you so much for answering the students' questions. And Alvarado Junior High, thank you very much. You guys did a great job, especially speaking up clearly and loudly. And let's give one final applause for the folks in Mission Control.
Thanks a lot, everybody.